Hi, everybody. Welcome to Chemistry 1100c. My name's Harry Breelman. You can call me Dr. B. And this is our very first meeting for this course. This is a chemistry course, and it's 5.5 weeks long. And what I'm going to do over the next half hour or so is just introduce you to the course, mostly show you how to go about doing things. We'll also talk a little bit about the first week core material. And so without further ado, why don't we go ahead and get started? What you see here is the homepage for the course. So here's the announcements. I wrote down some suggestions for the first 2 days. There's a welcome note here that I think you should read. And on the right side, if I go up a little bit, you'll see that we have just an image of me, not much information, and the live classroom session information. This is the live classroom right now. This is the link that we will always use. You can just click right there to go ahead and get started each week. That's pretty convenient. And this thing down here, I call this the slide deck. This is pretty important because this is kind of the entire course. If you click on any one of these weeks, so for example, if we click on week 1, it will give you the introduction. You can make the thing larger or smaller. And this has pretty much everything that you'll need. You'll see me referring to this heavily. So if you have some time, why don't you just page through it a little bit and become familiar with it. Okay, so let me tell you just a little bit about how the course operates and what we're up to. And for that, let me go back to the first slide, which is right here. There it is. These are clickable. See how you get the little hand when you go on them? So what I recommend is each Monday begins and you start a new week, go ahead and just click on that week and it'll bring you right to that single slide that is an attempt to summarize everything you need to know and to do for that week. It has a Monday through Sunday schedule, and hopefully you'll find that helpful. You can watch this video if you want to that shows how to use something that I call the templates. I'll have more to say about that in a minute, but essentially you'll be handing in things for points in this course, and sometimes it's a little unwieldy. Sometimes you'll see that the instructions say to take like as many as 20 shots with your phone of the screen and put them together in a zip file. I've come up with a system that I hope will be easier for you as well as for me, which is typically just 1 or 2 slides that have boxes that you fill in that accomplishes the same thing in a much easier method electronically. So that's the front page there. We'll talk a little bit about chemistry right now. We're here to study chemistry. Chemistry is awesome because you get to blow stuff up, absolutely. You can provide deep molecular answers to problems. When you're in your career, be it nursing or whatever, you might come to think of things on a molecular level, and that's what this course is all about. You're also here, I hope, because you'd like to make a difference, preferably for the better, and that is to help with a lot of the world's needs: cancer, pain, disease, COVID, whatever it might be. And I might as well mention that I realize that a lot of you guys are oftentimes frontline workers, first responders, and so I respect that. That's a very impressive thing. A lot of you also have kids. You're working more than one job. It's pretty crazy when I hear your stories of just what an effort you're putting in. Chemistry is a gateway to many great fields: medicine, engineering, nursing. There's so many different types of nurses that I read about when I hear your stories and what you're trying to, um, develop for a career. Let's have a look around. This is a screenshot of the front page, and so let's make sure you're familiar. And I'm guessing most of you are, but just in case. Make sure that you are in the right course. That one says spring 2020. We want to be in the fall term of 2020. There's messages there. I don't use that much. We have an electronic text that's very handy. Use that as a resource. Take advantage of that. There will be tests that use the Respondus Lockdown browser. Think of them more or less as time tests. Announcements. That's me. And there you go. So that's just some of the things. Right down here it says to really start, you'll start working your way down here. So click on each of these things. A module is basically a week. It's a 5.5 week course, and there are 6 modules. The last one is abbreviated. And there's a calendar. There used to be a calendar up here. Now that it's the new version, I don't think it's there, but if you poke around, you can find the calendar. And I did populate with the basic items. Moving on down, there's a grade center. That might be more for me. Your grades might be up higher. I enter the grades down there. There's your 6 modules. And if you click on one of these modules, you'll see something like this. This looks like the lessons. Now, they get a little confusing about the difference between a lesson and an assignment because sometimes they call their lessons assignments, but lessons, as far as I'm concerned, are the parts that have no point value. You don't hand them in. It's just learning the core material. And I think it's nice as a student to be able to just sit down for a day or two, not worry about handing anything in, but just try to take in the material. I mean, that's why you're here. So I would suggest Monday and Tuesday you go through these materials here. This is what is recommended in Power School, in Blackboard. But what I recommend you do is I'm going to show you some videos that I've created. I would recommend that first you watch the videos that I've made, and I'll show them in just a minute. They're typically 5 minutes or less. There's typically less than 10 of them, and it's my attempt to distill down this course into little bite-sized chunks that aren't that overwhelming. After you've done that, I would recommend you do all the things that are in here. Now, there is oftentimes 2 or 3 hours of work built into these things. So the idea, the time-saving idea, is that you listen to the videos, and then once it's time to go through the Blackboard reading and video material, if you find yourself nodding your head, skip along and go to the next thing. You've already learned it. If you find some topics where you didn't like the way I explained it, or you think it's something that's a little bit new, take the time to learn that. And by juggling those two in that manner, I think you can efficiently get through the material. I will say, frankly, that if you did absolutely everything in here, it consumes a massive amount of time and it's not worth any points. So spend the time that you think necessary to learn the material. Let me keep clicking here. Here's a calendar. This is from April 2020, but if you go to our calendar, you'll see something similar. The real big thing is that everything is due on Sunday night at midnight. So all of the assignments, and these typically consist of lab reports, well, labs, um, uh, and the assignment itself, which is a problem-solving exercise, and then the quiz. That's typically what you need to do each week. And I basically have marked down the Monday through Sunday pacing is generally the same, and then on Sunday night, by Sunday night, make sure you've handed everything in. That's the calendar there. This is a resource that you're welcome to print if you want. This is a periodic table that I made from scratch that I tried to design it to cover as many aspects of chemistry built into it as possible. Try to make the most helpful periodic table that I can. So use this if you like it. Here's some chemistry equations that we'll be using throughout the year. This is divided up by chapter. This is something I hand out to college students in other courses, and it might be a quick way to find a formula if you don't know it. Here's how things break down for the grading. Here's the percentages, so have a look at that. This, I think, you might find very helpful. This took me quite some time to develop, but it's what it is for each week, if you click on every one of these things, it sort of guides you through the unit. You begin on Tuesday, well, you begin really on Monday with learning by watching the video playlist. So I don't know if this is really in order, but if you click on the playlist, and it looks like I accidentally just did, you should see a series of videos. And since I created them as a playlist, they will play one after the other like a Netflix video. And you'll be able to watch all of them. So there's the Chapter 1, Module 1 playlist. Let me go back to this. There it is. Okay, the correct order that I think you should do things in is first watch the module, watch the videos, go to the lessons and work your way through that. Notice no point value. Attend the live classroom on Tuesday evening. I usually do a pre-recording, which means that could be something like what I'm doing right now, is recording what will be presented live. It gets a little bit different than when it's live, but you might find that useful. And then once you've gone through that, work your way through the assignments. It begins with a couple of labs, then the assignment itself, which is problem solving, then the review for the quiz, and then the quiz itself. The quiz review is designed to be specifically modeled to each question. So if you are learning something, rest assured there'll be a quiz question on it. And then we just repeat it for 5.5 weeks. Sometimes we have 3 labs, like on week 2. Sometimes we don't. Uh, and there it is. So click on each one of these. And why don't I go ahead and click on one of these just to get you familiar with it? Like here's the assignment for Module 3. So you're in your 3rd week. This is the problem solving assignment. And there it is. Fill in these blanks and hand it in, and you've completed the assignment. And I did a nice thing where I solved one of them for you. Notice that when I click on this and I type, you usually get something that's enterable. Not sure why I'm not there, but you can, there it is. I think there was just a delay. There it is. So when you type there, see that? You go ahead and can answer directly in there. If there's a way you prefer to do it, if these things you find annoying and you'd rather, can I just take a piece of paper and write out the answers? Absolutely. And then just send it to me. I just want this to be convenient for you. If you see how this says that there are, oh, I don't know, 12 questions on this sheet. If you just wrote 1 through 12 and handed them in on a separate sheet of paper and took a picture of it, as long as it's all done well and I can see it, full credit. You also have to do the second page, and so there's some more problems. So 1 through 20, I'm going to say 28, and that's it. That's what you're looking for the first assignment. So that's just an example. Okay, moving forward. Here we are with week 1. There's a lot here, but I did try to pack it in on purpose so that we could summarize week 1 efficiently. You can watch this pre-recorded video. You can read the things that you're going to learn. Here's the things that you need to do that are worth no points. And here's the actual items that are scored. And here's the points that they are worth. And this is the scoring guide for each, how they are scored. So in order, click there to watch the videos on Monday. Oh, this might have been slightly different. It begins with Wednesday, but oh yeah, this was let during the summer when things were a little different. But on day 1, watch the videos, uh, check out the lessons, attend the live classroom. This is always going to be Tuesday at 7. And then if you're ready for it, after 2 days, start working your way through things that have points. And for each one of those, you can click on it. We'll be doing some laboratory experiments. They are virtual in nature, and sometimes they can take a little bit getting used to. I mean, adding one solution to another online is not a normal thing. And so to help, we've created some videos that will help you along. More help here. I think there must be about 4 different videos you can watch in order to help you along to complete these labs. So take advantage of that. There's the assignment. There's the quiz review right there. And I think I will click on this. These, if you put these in order, they're designed to help you. Well, actually, it's one big video. It's a video designed to cover everything you need to know for the quiz, and it goes in order. Notice that I've tried to design this like flashcards, basically. You could ask yourself the question, pause it, and answer it before looking at the answer. I'm certain that's more beneficial. What's an observation? Convert this number to kilometers, convert that number to scientific notation, etc. If you can do all this stuff, you'll probably do very well on the quiz. And here are some other things about the unit. You can click on each one of these to go through the material in Blackboard. Here is the template for the first lab. Now, if you just click on it, you can find it that way too. So there's various ways you can find this. Here is the lab 1, lab 2, assignment. So what you need to do is literally hand these in for the assignment. And handing things in the first time might be a little bit confusing. So there's a video right on the first slide to help you with that. Talk to your friends. And once you get the hang of it, I think you'll find this is a good way to do things. There's the how to ace the quiz. And there you go. That finishes the unit. You know, before we sign off, let's take just a minute to look at these topics and just make sure we're comfortable with them. Now, we're getting a little ahead of the game because I'm guessing that most of you have not actually done the foundational work, but maybe you have some background in it. So let's talk about a few of these things. Perhaps you'll be learning these for the first time. Either way, let's go through a few of these questions. The scientific method. We usually summarize that as OHEC, observation, hypothesis, experiment, and conclusion. An observation is something that you see and wonder why. A hypothesis is an explanation without much evidence. An experiment is designed to test that hypothesis. If things are going well, you might develop a theory. That means all of your evidence supports something that is very likely the explanation for whatever it is you are testing. If it's always true, it's a law. And that's how some things about the scientific method. Scientists deal with very large and very small numbers, so they use the scientific notation frequently. This is an example of that. 2.38 times 10 to the 4 means we should make sure that there are 4 placeholders to the right of the decimal place, so that means we'll add 2. 23800, that would be 23,800. This number is much smaller. This is 2.384 times 10 to the, well, imagine a point right there. We need a number between 1 and 10, so 2.384 works, and it's 10 to the minus 1, 2, 3. To convert this to kilometers, recognize that you'll always have more meters than kilometers. Meters are small, kilometers are big. In fact, it's 1,000 times bigger, so it looks like this is 6.02 kilometers. Similarly, you might have to look up a conversion here and there. For example, 2.54 centimeters equals an inch. Write that down if you're handy, if you want to, for solving that problem. And that's SI units and conversions. Uncertainty in significant figures has to do with the precision of data. For example, for this number, I see a lot of zeros, all of which are insignificant because they are to the left. They're to the left of the numbers. Leading zeros, we call those. So that would only have 4 significant figures. This one is sandwiched, so it does matter. This would be 1, 2, 3, 4, 5 significant figures, etc. Density, as you may have heard, is equal to mass over volume, and this little triangle gives you all possible interrelationships. For instance, volume equals mass over density. Mass equals density times volume. And so using that, you can solve those problems. We also talk a little bit about energy, right? And it requires energy to work your way up, to go from like melting to boiling, right? And to go from solid to liquid gas requires energy. We call that endothermic. Since this thing is melting, it's going downhill, right? And therefore it would be releasing energy, exothermic. Condensing, similarly, is exothermic. Freezing is also working your way down from a liquid to a solid. I think every one of those would be actually exothermic. Okay, and that's a little review, and that introduces us to some of the topics. Well, welcome aboard, everybody. I hope you have a great time with this course. Email me whenever you need to if you have any questions, and welcome aboard.